So, and the intention of that whole S-TEST product is to cover basically two usage scenarios. One is really tailored for web applications. That means lab applications. I'm sorry, lab applications. If you have a prototype sensor you want to test and characterize, if you have completely newly developed MEMS technology, structures, anything that you need to verify in its physical behavior, that you need to test in terms of performance range and test in terms of behavior under temperature, any kind of lab scenario. This is what S-TEST Lab is all about. S-TEST Lab deals with the, let's say, lab environment. That means there's compact systems, usually placed on a desk of a developer, of a tester, even for software developers. And in many, many cases, when we talk about S-TEST Lab systems, they are not only the test of the sensor output, we also generate the stimulation effect. So we apply vibration to the sensor, or we apply different pressure levels. We test sensor boards, PCBs under temperature conditions, and all that combined with the capturing of the digital sensor output. Part of that S-TEST Lab setups can be also shock test systems for testing basically the robustness of designs, the robustness of PCBs, even anything that is system related, like how strong is your cable fixation to a PCB? Are my soldering pads big enough because my product is supposed to see high G acceleration forces? Things like that covered by S-TEST Lab. And as this is usually a wide range of things, we always ask customers to come to us to work with S-TEST Lab. S-TEST Fab, on the other hand, is totally tailored to mass production. That means quick and efficient, and most importantly, high parallel testing. I have a few slides to basically show this S-TEST Lab schematic setup. So normally you have lab PC, anything that runs the software. Then you have control interfaces that on one hand control the sensor stimulation. Here in my schematic diagram, this is an inertial sensor stimulus, like a vibration exciter, for example. And then this is the box here on the left side. In the middle, I have the small S-TEST unit, and that means we have here the tabletop unit that is usually used to capture just the digital output of the sensor. So this is a very typical schematic view of a lab setup, and the Fab setup. So here are example devices from SPEKTRA, different exciters here on the left-hand side, SE16 and the DRE01 for rotational excitation, our tabletop S-TEST unit for really small lab setups, and of course the lab PC. And on the Fab setups, what you get from SPEKTRA is usually only this part here on the right-hand side. Because the DOT handling system, everything that loads and unloads large quantities of sensors and applies different forces, inertial stimulus, magnetic fields, acoustic stimulation for microphones, anything that is required to stimulate the sensor, that is done usually by partners. So having said that, so this in the end is what an S-TEST Lab on the left-hand side and an S-TEST Fab looks like.